Hello students, in previous lecture we have studied about the different types of salts and hydrolysis of salt. Then we have discussed the examples of different types of salts. Then today we are going to discussing on hydrolysis of different types of salts, taking one of the example from it. That is, first of all, see here, hydrolysis of salt of strong acid, strong base. Then here example of salt of strong acid, strong base is NaCl or KCl or Na2SO4 or K2SO4. Then see here, we will discussing on the hydrolysis of salt of strong acid, strong base. The example of salt of strong acid, strong base is NaCl. See here, NaCl is a salt of, it is a salt of strong acid, that is HCl, and strong base, that is NaOH. Then see here, when NaCl salt, that is common salt, NaCl means common salt, which is used in food, that NaCl salt, it is dissolved in water. When it is dissolved in water at given temperature, then the NaCl, the number of moles of NaCl get dissolved in aqueous medium. Then as it is a salt of strong acid and strong base, therefore the salt itself is also salt of strong acid, strong base is also strong. It is a strong electrolyte. All of you studied about that, the different types of salt, that is 4 types of salts. That is salt of strong acid, strong base. It is also strong electrolyte. That means this type of salts dissociate completely in aqueous medium. Similarly, salt of strong acid, weak base are also strong electrolyte. Strong electrolyte, as well as salt of weak acid, strong base is also strong electrolyte. And salt of weak acid, weak base are weak electrolyte. That means here, out of 4 types of salt, 3 types of salts are strong electrolyte, and only salt of weak acid, weak base is weak electrolyte. That means these 3 types of salt, when dissolved in water, it dissociates completely and gives more and more ions. And when the strong electrolyte, that is here, NaCl is a salt of strong acid and strong base, which is a strong electrolyte. It dissociates completely. For complete dissociation, that full arrow is used here. That arrow indicates that NaCl, when dissolved in aqueous medium, then it dissociates into Na plus Cl minus ion. Then here undissociated molecules of NaCl is not there in the solution, and the solution, aqueous solution of NaCl contains large number of Na plus ion and Cl minus ions are there. And see here, the water which contains, that is water which dissociate into H plus ion, that is water dissociate to gives H3O plus and OH minus ions. Then see here, the water dissociate feebly, therefore equilibrium is attained between hydronium ion, hydroxide ion and undissociated water molecule, as it is a weak electrolyte and it is a strong electrolyte. Then what is hydrolysis of salt? I have mentioned it in previous lecture. That is, if the salt dissolved in water, then the dissociated ions of salts, that is cation or anion of salt, if it reacts with ions of water, that means if Na plus ion or Cl minus ion or both ions interacts or reacts with ions of hydronium ion, hydroxide ion of water, and if solution becomes acidic or basic, then it is said that that type of salt may undergoes hydrolysis. Then see here, if here the dissociated ion of this salt, that is Na plus and Cl minus ion, if Na plus reacts with OH minus ion, then it gives NaOH. That means when NaCl dissolved in water, then it gives, if NaOH and HCl, and as NaOH and HCl both are strong electrolyte, therefore in aqueous medium, medium is aqueous, there water is there, therefore that NaOH and HCl which dissociate again into, or it dissociate completely to gives Na plus OH minus ion, and HCl dissociate to gives H plus and Cl minus ion, or it is hydronium ion, H plus or H3O plus ion, that is hydronium ion. And here, as NaCl is strong electrolyte, therefore it is also dissociate into Na plus and Cl minus ion. That means in solution, NaCl in aqueous medium, as it is a strong electrolyte, it dissociate to gives these ions, Na plus and Cl minus ion, and NaOH which dissociate completely to gives Na plus and OH minus ion, and HCl dissociate to gives hydronium ion and Cl minus ion. Therefore, when common salt dissolved in water, it gives Na plus and Cl minus ions. But that Na plus or Cl minus, both ions does not have tendency, it is important that neither Na plus or Cl minus have tendency to interact with ions of water. That means Na plus does not react with OH minus ion to give NaOH, and Cl minus does not react with H plus ion to give HCl, because if they reacts to gives NaOH and HCl, again NaOH and HCl, they dissociate to gives their ions, as they are strong electrolyte, and therefore the Na plus ion and Cl minus ion of NaCl in aqueous medium, they does not have tendency, that means Na plus and Cl minus ion they do not have tendency to reacts with ions of water, and therefore as Na plus and Cl minus, that is cation and anion of salt of strong acid and strong base, it does not react with H3O plus ion and OH minus ion. Therefore the molar concentration of H3O plus and molar concentration of OH minus ion remains equal. That means equality of molar concentration of H plus ion, that is H3O plus ion, and OH minus ion does not disturb. That means it remains as it is. It remains equal. Therefore the solution remains neutral. Therefore solution does not become acidic or basic. Therefore it is said that salt of strong acid, strong base does not undergoes hydrolysis. Why? Because here equality of concentration of hydronium ion and OH minus ion does not get disturbed. Therefore it is said that the salt of strong acid, strong base does not undergoes hydrolysis. According to definition of hydrolysis, if cation or anion reacts with the ions of water and if it gives solution acidic or basic, then that salt undergoes hydrolysis, or hydrolysis of that type of salt takes place. Therefore here, as Na plus and Cl minus, both ions do not have tendency to react with hydronium ion and OH minus ion. Therefore, and solution does not becomes neither acidic or basic. Therefore it is said that salt of strong acid, strong base does not undergoes hydrolysis. Then the next type of salt, that is hydrolysis of salt of strong acid, weak base. Then examples of these type of salts we have already discussed in previous lecture. Then taking one of the example of salt of strong acid, strong base, we can discuss about the hydrolysis of salt of strong acid, strong base. Then here example of salt of strong acid, weak base, strong acid, weak base, that is CuSO4. See here, CuSO4 is a salt of strong acid, weak base, and here it is a salt of strong acid, that is H2SO4, sulfuric acid, and weak base, that is CuOH twice. See here how to determine the salts or predict the acid or base from which it is obtained. Then see here, as CuSO4, which contains Cu2 plus ions, as CuSO4 is a strong electrolyte because salt of strong acid, weak base is also strong electrolyte. Therefore it dissociates completely to gives Cu2 plus ion and SO4 2 minus ions in aqueous medium. Then see here the cation of this salt, if it reacts with OH minus ion, then it gives CuOH twice, and if SO4 2 minus reacts with H plus ion, then it gives H2SO4. Then see here, CuOH twice is a weak electrolyte, but H2SO4 is a strong electrolyte. Therefore, SO4 2 minus when interacts with H plus ion of water, then it gives strong acid. Therefore, that SO4 2 minus ion, therefore SO4 2 minus ion do not have tendency to react with H plus ion of water. If it reacts with H plus ion of water, then it gives the strong acid, that is H2SO4, but H2SO4 is a strong acid or strong electrolyte. Therefore, again it dissociates into SO4 2 minus and H plus ion. Then here the Cu2 plus ion of that salt, which have tendency to interact with water. That means the cation of CuSO4 salt, it has tendency to interact with water and it gives CuOH twice, and with the formation of H plus ions. That means here Cu2 plus ion reacts with OH minus ion of water, and therefore it gives CuOH twice, which is a weak electrolyte. Therefore, dissociation of this salt is very less, and unionized CuOH twice, unionized CuOH twice formation takes place with formation of H plus ion, or that H plus ion in water, it reacts with water molecule to gives hydronium ion. That means when CuSO4 dissolved in aqueous medium, it gives Cu2 plus SO4 2 minus ions. That means these two types of ions are present in aqueous solution of CuSO4. Then out of this, Cu2 plus have tendency to react with water, and it reacts with OH minus ion of water to gives unionized CuOH twice, which is weak electrolyte, with the formation of H plus, or that H plus is converted into hydronium ion. That means here overall there are SO4 2 minus H plus ion, that is H3O plus ion, and CuOH twice, that is unionized CuOH twice, that is copper hydroxide, unionized molecule, are present in the aqueous solution of CuSO4. That means the resultant solution. The resultant solution means the solution which is obtained when CuSO4 dissolved into aqueous medium. That resultant solution contains SO4 2 minus ions, H3O plus ions, and unionized CuOH twice. Then, as that solution contains CuOH twice in it, therefore solution of CuSO4 becomes turbid. Turbid, that means non-transparent. Transparent, NaCl common salt when dissolved in water, the solution becomes transparent. Salt solution is transparent. But chalk powder solution, chalk powder when added into the aqueous medium, then that solution is a turbid, whitish, or it becomes turbid. Or soil when dissolved in water, then that solution becomes turbid. Like that, here CuSO4 when dissolved in water, then that blue colored solution, blue colored solution which is turbid in nature. It is because of CuOH twice formation takes place. Here in this solution, CuOH twice unionized molecules of copper hydroxides are there, and copper hydroxide is a sparingly soluble salt. Sparingly soluble salt. Sparingly soluble salt. That means it remains undissociated. Undissociated, that is chalk powder. It does not dissolve completely, and therefore it gives turbid solution. Like that, the solubility of CuOH twice is very, very less. Therefore, it gives turbid solution. That means non-transparent solution. Then, here, presence of hydronium ion. Due to presence of hydronium ion present in it, that means overall solution contains H plus ions, that means hydronium ion. Therefore, the resultant solution is acidic in nature. All of you have studied about the acidic, basic and neutral nature of the solutions of the different types of salt. If the aqueous solution of the substance, if it contains H plus ion or hydronium ion greater than the OH minus ion, then that solution is acidic. If the aqueous solution of the substance, if it contains greater number of OH minus ion than the H plus ion, then that solution is basic. And if the aqueous solution of salt, if it contains equal number of moles of hydronium ion and OH minus ion, that is H plus ion and OH minus ion, then that solution is neutral. Then in this solution, hydronium ions are greater. Therefore, the solution, aqueous solution of CuSO4, that is aqueous solution of salt of strong acid, weak base, is acidic in nature. Then according to the definition or concept of hydrolysis, it is said that salt of strong acid, weak base, salt of strong acid, weak base undergoes hydrolysis. Undergoes hydrolysis because here the cation of that salt of strong acid, weak base reacts with water to gives the resultant solution contains H plus ions, or the solution becomes acidic. Therefore, this type of salt undergoes hydrolysis. But see here, because of formation of CuOH twice, that is sparingly soluble salt. Sparingly soluble salt means the salt which dissociate or dissolve very, very less amount, and undissociated molecules remains as it is. Therefore, solution becomes turbid. and to make that solution clear or transparent, to clear blue color solution to becomes clear, we have to add H3O plus ions, that means H plus ions, and H plus ions are present in acid. Therefore, to increase the concentration of H3O plus in this solution, if the concentration of H3O plus increases, then equilibrium is shifted towards left and CuOH twice is converted into Cu2 plus ion and OH minus ions. Therefore, here CuOH twice get dissolved in acidic solution. Therefore, to clear this solution, we have to add H2SO4 in it, and that is about the salt of hydrolysis of salt of strong acid weak base. Then the next one type, that is third type of salt, is salt of weak acid strong base, that is weak acid strong base. As it is a salt of weak acid strong base, itself salt is also strong electrolyte. Then taking one of the example of this type of salt, we have to determine whether this type of salt undergoes hydrolysis or not. Then, for example, CH3COONA is a salt of weak acid, that is acetic acid, CH3COH, and strong base, that is NaOH. Then see here, when CH3CONA, that means sodium acetate, as it is a salt of weak acid strong base, and the nature of this salt is strong salt or strong electrolyte. It is a strong electrolyte. Therefore, in aqueous medium, it dissociates completely, that is CH3CO minus plus Na plus in aqueous medium, and here CH3CO minus, which interacts with H plus ion or hydronium ion of water to gives CH3CO minus. That anion interacts with H plus or with water, ion of water. It gives CH3COOH plus OH minus ion, and Na plus ion, if it reacts with OH minus ion, then it gives NaOH, and again NaOH is a strong electrolyte, and again it dissociates completely into Na plus and OH minus ion. Therefore, Na plus does not have tendency, Na plus, it does not have tendency to reacts with water, and therefore only CH3CO minus, that is acetate ion have tendency to reacts with water to gives CH3COH and OH minus ion. That means the resultant solution, the solution that is aqueous solution of sodium acetate, that is CH3CONA, which contains CH3COOH unionized molecule and Na plus and OH minus ion That means the resultant solution, that means the solution of aqueous solution of sodium acetate salt when it is dissolved in water, it contains unionized acetic acid molecule Na plus and OH minus ion. Then therefore the resultant solution of aqueous salt solution which contains OH minus ions present in it. Therefore the solution is, that is salt solution, that is salt solution of aqueous solution of weak acid strong base is basic in nature, that is alkaline in nature. Therefore it is said that salt of weak acid strong base are also undergoes hydrolysis. That means here the anion of salt of weak acid strong base reacts with water to give OH minus ions, and because of OH minus ion the resultant solution is basic in nature or alkaline in nature. Therefore it is said that salt of weak acid strong base also undergoes hydrolysis. That means here we have studied about the hydrolysis of three types of salts, that is hydrolysis of salt of strong acid strong base. Here salt of strong acid strong base, it is said that that type of salt does not undergoes hydrolysis, but the salt of strong acid weak base as well as the salt of weak acid strong base, these two types of salts undergoes hydrolysis. That is about the hydrolysis of different types of salts. Then fourth one type of salt, that is salt of weak acid weak base. Then the salt of weak acid weak base itself, it is a weak electrolyte, but depending upon the salt which is obtained from acid and base, the strength of or dissociation constant of acid or base from which it is obtained, dissociation constant of weak acid or weak base from which it is obtained, depending upon the strength of weak acid and weak base, there are three categories of salt of weak acid weak base. Therefore we have to discuss about the hydrolysis of salt of weak acid weak base in next lecture. Thank you.